descriptive statistics, and we stopped at I think the third slide, talking about contingency table. So that's where we are going to continue this session. Oh, sorry. I'm trying to plug my system. All right. Can you hear me?
Yes, I can.
Okay, so we are here live on the third slide. Yeah. So creating contingency table. So I created a simple contingency table. Did you see the part where I created a contingency table? I think
No.
it went. Okay, let me show you again. So for instance, I created this data frame. So let me see whether the data frame is still open. So this is what it's going to look like. You can see it's my console, right? So I have two columns, country and fruits. Now, if I want to know, see like a summarized table of these two columns, telling me that okay, how many times do you have Nigeria and banana or Nigeria and apple? So what this is going to do is that if I say table of DF and DF has two columns, so it's going to create the unique column of country as rows and unique column of fruits. So unique entries of country as rows and unique entries of fruit as column, and find when those entries correlate. So what do I mean by that? So if I should run this now, this is telling me that Ghana and apple occurred once in the data frame. Ghana and banana occurred once. Ghana and orange did not occur at all. Nigeria and apple appeared twice. Nigeria and banana appeared once. Nigeria and orange did not appear at all. South Africa and apple did not occur. South Africa and banana did not occur, but South Africa and orange occurred. So it just give you a summary in that chart. You understand?
Okay. Oh, okay. I
Yeah.
get it.
So as you can see, Nigeria and banana, no. Nigeria and apple, that's two times. That's why you have two here, Nigeria and apple.
That like
You said?
so now it's like this matrix one.
Yes. Now, this can get complicated when it's more than two columns. It's going to be more complicated when it's more than two columns. So, for instance, this is a data frame. It has three columns: height, plants, and water. Now, if you do table of this guy, so it has three columns, so it can compress the three of them together in a single matrix. So what it's going to do is that it's going to break them into levels depending. So this is the result of what I have table PW. Now, what happened here is that he now created tables for each levels in the water column. So what do I mean? It's going to create a table when water is HI, that is I. It finds the relationship in this height and plant. When water is mid, you find the relationship between height and plant, and when water is low, you find the relationship between height and plant. So it creates a table for each categories in water corresponding to height and plant. Do you understand?
Yes.
Like, do you really understand what I just said?
Yes. Abi.
Okay. Let me have a feeling. What did you say?
Let me put on now so I can get it better.
Okay, so I will do something like that in R now. So I'm going to extend this data frame to three columns. So I'm going to say level, that means LVL, is equals to combine repeat 1 3 times and repeat 2 3 times. So I'm going to do this. I'm going to create that one again. All right, good. I'll now use table of DF. Now look at what you have. Now for level 1, so let me call DF before I call the table. Can you see my screen? You can see it, right? And this is how the data frame looks like. Now if I should create table of DF, now it now considers for level 1, when level is 1, it creates the unique country and the unique food and checks when level is 1. When did Ghana and Apple occur? So when level is 1, Ghana Apple occurred once, right? We put 1 here.
Yes.
When level is 1, when the Ghana and banana, how many times did they occur? Once. That's when level is 1. When level is 1, Ghana and what about Ghana and orange? Did they occur when level is 1? No, Ghana and orange did not occur. So they go to 0. So after I've done that for level 1, then it goes to level 2. So when level is 2, it checks the relationship again. How many times did they occur? Then it
So you missed level. Oh, what's level? Yeah.
that's the unique entries in this level column. 1 and 2. I just have 1 and 2.
Mhm.
Do you understand?
Okay.
You understand, or do I have to explain in another way?
I do. I get it now.
Okay. Now, so creating custom contingency table. So it's not necessary you put table and pass the data frame inside it. You can select the columns you wish to create table from. You can specify the columns you need to pick, and or you can specify the column that will be at the row side or at the column side. So how do we do that? Now, so this is the format: table into bracket column 1, comma column 2, comma, depending on how many columns you want to put. But you know, when the column is more than 2, it becomes more complicated, but it doesn't matter. So here you have table for 2 columns, and this is very pretty simple. It has the simplest kind of table is only the one that has only 1 column. That is going to aggregate the number of occurrence of variables in that regard. So let me show you that one. So here, if I say table of the country column in DF, so what is showing me here is that it's telling me that in the countries column in DF, Ghana is appearing twice, Nigeria is appearing 3 times, and South Africa is appearing once. We just aggregate it in that regard. Now, and you're comparing 2 columns, you know how it does that. It checks 5 and I. When does it occur? How many times does it occur? It doesn't occur at all. 0. 5 and low, how many times does it occur? Once. 5 and mid, how many times does it occur in the data? 0 times. 6 and I, 0, then like a frequency kind of thing. Now, yeah. So moving forward, now you have a matrix like this. You want to create a contingency table from matrix object. This is a matrix. Now let's see. Here and I put table bed. Table bed. Now, what is this guy doing for us? What did this guy just did? Table bed. If you look at this, what does it look like it is doing actually? Let's go back to the bed table. This is the bed matrix. So what do you think that table gave us? What do you think it gave us?
Which one?
This table, this is what you are seeing here. It was derived from the matrix bed. It was derived from this matrix called bed. We now do table of this
Bed.
bed. Yes. So table of this bed matrix,
Okay.
and it gave us this result. So what is just this? It create a frequency table comprising of the data in this guy. It's not using the column names or the row names. It's just using the numbers inside this thing. So it's what it just is that you now take all the numbers here, like the unique numbers, arrange it in ascending order. That's 0, 2, 3, 4, 5, 6 up to 50. Then check how many times is 0 occurring in the matrix. So let's go back to the matrix. You can see that I have 1 0 here, another one 2, another one 3, another one 4, another one 5, another one 6, another one 7, then 8, then 9. So 0 is occurring 9 times in the matrix, as you can see here. Now, the next number that we have in the matrix is,
Okay, sir.
he said,
The I can only see the bed matrix.
What can you see the table, the command table into bracket bed that I'm showing you now?
Yes, yes.
Hmm?
I can. Yes, I can see now. Look now.
So, and it's also telling us that 2 in that matrix is occurring 4 times, 3 in that matrix is occurring 2 times, till I get to 50. So that's what it's just showing us there. Now, likewise, using square bracket to pick required rows. So in this case now, I'm saying that um, give me the table of bed for column 1 and for column 2. You know it's going to create a simple contiguous table, right? Now, I'm now saying that, okay, for this bed column 1 and bed column 2, give me the name. So give it a name, give the table a dimension name, say for the rows and the column. So the row is going to be called GDN and the column is going to be called edge, as you can see in this result. So, but what's this table actually doing? So it goes, I'll go back to the matrix again. This, I'm picking what is it picking? Column 1 and what? Column 2. And column 1 is this guy, right? And
Before, Abi.
yes, column 1 is this garden column. And column 2 is this edge, what's it called? Edge row. Are you with me? So you just create the unique entry of what? Of column 2, 0, 3, 10, 16. So if I go back to column 2, you can see the unique column is 0, 3, 10, and 16. That's the unique column. So it also picks the unique column here and plot it against the unique column here. So it's not showing the whole records for the rows here. So it's not showing everything. Let me scroll down. Okay, it's not showing it. It's just showing just 4, but there are still other values down. So this one is saying that 4 and 0 occur once. So if we check 4, see 4 and 0 is only occurring once. So 4 is not occurring with any number again. So another thing is going to check again. It's going to go to 9. 9 and 0, are they occurring? No. 9 and 3, they are occurring once. It records it. So it checks 9 and 10, is they occurring? If it does not occur, put 0 and like that. So like the normal simple contingency table. Now, and here we're saying using rules of a data frame in the contingency table. You can also use rules depending on what you want to achieve. So just similarly as we have seen in previous slide, this one is just picking a vector against another vector and giving it a name for the row and column respectively. So that's just the about contingency table. Now we have the T function. The T function here, can you see what I'm showing you?
Yes.
This is
T of
used,
TW.
yes. So this is to transpose the data set. It's to transpose
Yes.
like a matrix if you have a matrix, it turns the rows to be columns and columns to rows. You know what transpose does now?
Sure.
Yeah, let me allow somebody into it.
Okay.
So that's basically what the T command does for you. So you can use the T command inside a table function also. But this line, what it's saying is that transpose FW, this matrix, transpose this matrix, pick the first column together with transpose this matrix, pick the second column, create a table for it, a contingency table. Now give it this name for the rows and columns in the contingency table. So the row is going to be Tor and the columns is going to be what called Tori. So that's what this is going to do for you. And here we have some commands here for selecting part of a table object. But this one is just showing you the structure of an object. This str function is to show you the structure of a particular object. But in Python, this is used to convert to string, right? This is used to convert to string. Now, this one we are just trying to select. This is like subsetting. This is okay. Give me the first 3 rows for all the columns, because you can see after the comma nothing was specified. It means give me all the columns. But this is saying give me the first 3 rows corresponding to what all the columns. This is saying give me the first 3 rows corresponding to what the first column. This is saying give me the first 3 rows corresponding to what to the first and what second column. Now this is saying give me all the records for the what for the I column. While this is saying give me the first 3 records, that is first 3 rows for the what I and mid column in this particular what maybe matrix or data frame. You know, it's 2 dimensions, so it's going to be a matrix or a data frame. Now this is saying give me the first 3 records in what the mid and I column respectively, and this one is saying give me all the records for the I column and the column in position 3. Displays 2 columns using a mix of name and number. But let me try this out. Let me actually try this command out. I've not done something like this before, so I want to see what's going to happen. Let's try it out. This one that has a mix of name and number at the same time. So let me call the df column. Let me call all the records corresponding to what is it called? The level. So let me use the level column, LVL, and the first column. Let's see what's going to bring out. It's saying undefined column selected. So I don't think that's going to work out. I don't think that's going to work out. Having a mix of character and string at the same time, that's not going to work out. So I just wanted to be sure. So this wouldn't work out. You can't do this. I don't think you can do this. Yeah. So this length gives you if you do this with a data from a matrix, it's going to give you the number of columns you have. So let me show you what I'm talking about. Now in Python they use len. So sometimes when I'm writing out code and I want to find length, I usually use this len sometimes. I would think I'm writing in Python, so sometimes I just write len. So if I do len length of df, you can see it gave me 3. It's telling me that I have 3 columns. So usually with matrix and data frames, give you the number of columns you have. But if you want to know the number of records, all you just need to do is you can just specify a particular column and find the length. So just pick one column in for all the records and do this. It's going to give you the number of records. You can see that here I have 6. It is showing me the number of rows in that data frame. So That's just the trick behind it. Okay, so converting an object into a table. So let's say for example, you have a uh, what is it called? You can have a data a data frame, for example. You can first of all convert it to a matrix, then from there convert it to a table. Convert it to a table. So it works that way. It works that way. Now, so let me show you something. This I think this MF is supposed to be a data frame. So let's say I have this data frame called DF. You know, DF is a data frame, and how can you know it's a data frame? So you just take the class as DF. You can see to tell you that it's what it is. So now if I say as dot table, let's see how this is going to work out. DF. You can see error in as dot table cannot coerce to a table. So you cannot coerce a data frame into a table directly. So first of all, you have to convert it to a matrix. Okay, before you now convert it into a table. So if I run this, it just works fine, as you can see here. So it's now in table format now. All right. So now testing for table objects. So most of the times, if you are testing for objects in R, we usually use the is function, then followed by the object, followed by the method. So like is dot table, like you're checking, is it a table? That's just basically what it's just saying. You can say is dot data dot frame. I think you can say is dot vector, is dot matrix, or anything. So let's say I have the df now, and say is dot, let's say vector, is dot vector of df. You can see it gave me false because df is not a vector. What if I say is dot matrix? It doesn't give me false. Okay, let me now check is dot data dot frame of df. It gave me what? True. So it's telling me that it's a data frame. So it's just to ask question, it's a test. Is this thing this? Though you can actually just say, you can just check the class. You can, so it's just like if you want to run create a conditional statement on a particular object, you want to check it. So it's not uh it's not going to be that flexible for you to say class. So you want to check a particular object now. I'm not saying if, then I'm not saying class of what is it called? Okay, let me just run this. The class, what's the class of DF again? Data frame, Abi. This is it, right? If I want to now check whether it's a data frame, I'll now say copy this, I'll now copy this, I'll now say class DF equals this. Now, if I want this, you can see it is true, right? Instead of doing this, I can just say is dot data frame, then pass the. So instead of doing this, I can just do this. So any which way you want to go about it, it's just the way you think about it. So it's just better you just use this. So if instead of me to write if, then pass this whole long statement inside this place, trying to compare. I'll just put if is dot if is dot data frame df. I'll just put this inside this place instead of this long statement. It checks if this is true. I will now say print. We will enter conditional statement now. If this condition print what is it called? It is a data frame. So if I pass this condition to an if statement, then if this condition proves to be true, then it's going to run what is inside the conditional statement. So if I should run this now, so you just printed the stuff that it is a data frame. So that's testing for you. Now I'm already entering into conditional statement. We are going to get there in the next what's it called? I think in the next session. So moving forward. You have complex flat tables. So here I think we'll be talking about F tab. Uh, um, so let me just move forward. So it's similar to what the table function is actually going to do for you, but then so here I'm saying that I think I've talked about the width and the width function before. The yeah, width and the within function and all of that, and the which function. I think I've talked about the which function also. Now here I'm saying that with this, I don't know what PW is. I think maybe PW is a matrix or something. I don't know. I don't know. Maybe it's a matrix or a data frame. So I'm saying with PW, uh, perform F table, a flat table when height is equal to 14 together with water together with plants. Here I'm saying with this guy, perform a flat table when height is equal to 14, water is equal to I, and pick for plant. Now, what is this guy going to do for you? Now, it has three columns: height, water, and plant. Now, it's going to be similar to what the table into brackets, the
Over.
three, the three columns is going to be for you in similar manner. So let's say, for example, I come here using the df column, and I say f table. Let me use the width function. So with the df data set, perform f table of what level when level is equal to 1 for country and foot. Let me run this. You can see what you have. So you can see what you have. Instead of me doing what's it called? Instead of me having levels for the table function, you now having it as a single matrix, and the level is now showing side by side. This for the level. The level here is the LBL variable. Don't confuse what I'm saying with LBL. Like, in the level column we have 1 and 2. So I'm not saying perform F table for level equals 1. This is when level is not equals to 1. Hello. This is when level is not equals to 1. Now it now creates a contingency table for country and foot in that order. So these are the unique countries for when level is not equals to 1, because it's false. It's going to be true when this is equals to 1. So that's why you have true here. So when it is not equals to 1, I have Ghana and apple not occurring, Ghana and banana not occurring, Ghana and orange not occurring. I have Nigeria and apple occurring twice when level is 2. I have Nigeria and banana not occurring, Nigeria and orange. But when level is now 1, that's when you have true here. It does another comparison. Ghana and apple is occurring once. Ghana and banana is occurring once. Ghana and orange is occurring just 0 times. Nigeria and apple occurring 0 times. So if I use table function of BF, the way it's going to do this is going to be different from what you are seeing here. Instead of it to be compact like this, it's going to give you on a level basis. So here, this is when level is equal to 1. You can see that this result here is similar to what you have here. This when level is equal to 1. Now when level is equal to 2, this is the result you have. As this when LBL column is 2, which is similar to what you have in this top corner. So this is when level is not equal to 1. So it's just as that. Hello, are you still with me? I can't hear anybody.
Yes, like the phone.
Okay. So is this F table? This F table, is it flat table? Is it all well understood? So it creates a frequency table. It is true when LBL is 1, but false for other categories. The LBL column has 2 unique values, 1 and 2. So this is when level is 1, because I specified that give me the F table when LVL is 1. So it is true for 1, but for other cases it is false. And because I have only 1 and 2, that's why you have only one false value here. So yeah, that's basically it. So here now, I said F table of height, plant, and water. Now let me go back to my house studio. This is going to do for country, fruit, and what? And level. If I want this is the way it's going to look like, right? Now let me use F table to perform the same operation. So I'll say, let me say with F table, with DF, perform F table of country, fruit, level. Let me run this. You can see the way it brought it, but this one is not bringing it. Is bringing the country as level, but I want it to bring level, this LVL column, as the factors or the levels. So I'll just put this LVL at the beginning. I'll put it here. Can run this again. So you have this. So for level 1, this is the frequency table for the country and what? And food. For level 2, this is what you have. It brought everything as a single matrix compared to the table function, which is now doing what's it called? For level 1, it brought a separate matrix, and for level 2, it now brought another separate matrix. But this one is compact together like this way, which makes it more like readable. You understand? Hello. Hello.
Hi, hello. I'm following.
Okay. Do you understand that concept, or do you have to explain in another way? Okay. Let me use a practical scenario. Farida, if you are not, whenever you are not talking, just help me to mute your mic. It's gonna be easy for us that way. So, for example, I have a table that has a department column, and I have another table having the employee names. Then I have a table. I have a table that has department name. In that table, we have column department. I have another column called employee names that have names of employee. Then another column is showing projects projects that employees have worked on. Okay, good. Now, and I want to do F table. I want to create a contingency table with those 3 columns. And what is my aim? Okay, don't let me go to contingency table. Now, I want to create a simple table that's going to tell me in each department, give me employees that give me employees, the number of projects a particular employee has worked on in each department. So let me come again. I have a table that has department name, employee names, and project employees have worked on. Now, a particular employee must have worked in maybe 3 projects, 4 projects, or just 1 project. So let's say you have project 1, let's say a particular employee A has worked on project 1, project 5, project 6. I've worked in a lot of projects. Now, so the table is going to be showing something like on the factor level. If I have like 4 departments, so for each department, I'm going to see unique employee names. Let's say I have 5 employees. So for department A, I will have those unique 5 employees on a row side. Then I'm going to have the project on the column side, the unique projects on the column side. Now, the table can be showing that employee A, project 1, employee A, project 1 again, employee A, project 1 again. That is showing that employee A has worked on project 1 like 3 times. So in that table, it's going to show me department, and it's possible that a particular employee can belong to more than 1 department. So that table is going to give me the information that in this particular department, let's say department A, employee A has worked in project 1 maybe 3 times or 2, depending on the number of occurrences in that table. Then it's going to check employee A with project 2 again. If employee A has worked with project 2, it tells me the number of times employee A has worked in that project, or give me 0 if the person has not worked in that project. It means employee A has not worked in that project. Then it checks for other projects. If I have 3 projects, it checks employee A with all those 3 projects. Then it goes to employee B and checks with all those 3 projects again, the number of times they have worked on that project. Then after that part is done, you now go to the next department and check for those employees again, regards to what the project they have done also. So that's what a contingency table is going to be. It's just like to aggregate your data and give you information in that regard. Like it's just giving you a summary, like a frequency table. So okay, I think that is well explained. And I told you earlier that which function is used to get positions of records. Now I will explain. Now you have logical operations and we have comparison operators. The comparison operators give you Boolean results. So the comparison of operators you have are comparison. You have like the double equality sign, the greater than sign, the less than sign, the greater than or equal to sign, the less than or equal to sign. Now, whenever you use these operators, you get a Boolean result. Are you with me? Now, say for example, in this DF column, I have this. So let's say I want to now check for column LBL. I want to check the values that are equal to 1. I use double equality. I'm trying to check. So if I run this now, you can see I have true, 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 false, false, false. These are Boolean values. It means that for the first 3 records, I have 1, 1. And for the last 3 records, those records are not equal to 1. Now, in this case, I might have this true, false value not arranged in a particular order. Or I might be interested in what position in my vector or my data frame is this result true. I can use the which function to do that. I will now say which into brackets this comparison, this logical operator. I will now say, sorry, this comparison operation here. I will now say which of this. Then this is going to give me the time when this guy is what is true. This guy is true for the first entry. It's true for the second entry and also true for the what? For the third entry. And it's not give me for this one. It's just I'm just interested in the position whereby this guy is actually true. This is going to be interesting when you're doing formatting, subsetting of data and all of that. So let me use another case scenario. I have the vector uh, object VEC. So I want to now check which when is VEC say greater than 3. And if I should run this, I have 3, 6, 7, 8. It's saying that okay, at position 3, I have vector to be greater than 3. At position 6, I have vector to be greater than 3. At position 7, I also have vector, and at position 8, I have vector to be greater than 3. So it gives me that position like that. Are you with me? But if I want to subset, say, give me those guys in vector, that is in VEC, that are greater than 3. I will now say VEC, and how do you subset? I use a square bracket. But I want to subset based on a particular logical operation. Say when VEC is greater than 3. Give me VEC when VEC is greater than 3. This is just what it means. So if I should run this, it's giving me this result. It's going to bring it together with the NA value. So if you don't mind. So these are the values that are greater than 3 in VEC. So these stuffs are really, really very interesting. When you are subsetting data, it's going to help you a lot. So, and these which functions helps you to get the positions of whereby this condition is true. So also testing flag table, I think it's talked about class and all of that. So I don't think this one is important again. So moving to the last part of this session, we've talked about row sums and row means, the apply function. We have prop.table. You have prop.table. This is going to return the content of data frame matches or tables as a proportion of the total specified margin. So this is going to say, okay, let me go to an illustration. Next slide. Okay. Oh, they didn't even talk about that. I'm coming. So if I say prop.table, let me use a particular matrix. I'm wasting much time in this session. I don't know. So let me create a matrix. Let me say I have a matrix. Okay, this is a matrix. If I now say prop.table, what is it called? I'll specify the data I want to work with. That's this matrix. Give me on what's it called? On a row, give me on a column level 2 as the margin, then use sum for it as the function. And let me run this. Oh, sorry. How did that come over there? Why? Sorry. So oh, total. I think I'm not getting something here. Okay, let me see this. Okay, this is cost tabulation. I'm not coming to this yet. So let me quickly explain this population table. I'm supposed to have what this is supposed to do for me is that it's going to give me a proportion of these columns corresponding to the sum of this matrix. Let me try this. No. Where is this now? Let me use the FUN. Hang on a second. So I'm just using this. I'm not just using the right syntax to do this. Let me check. So many things to put together. Please hold on. Because this aspect is actually very essential. How can you define this? Okay. I don't think I need that function part of it. So, okay. I don't think I need this guy. So let me move this. So two. So as you can see here, what it just did is, let me call the matrix again. So this is the matrix. So I'm going to run this again. This is what you have. So it did this on a column level, and it gave me the proportion of each of these for this column. So it's in on a column level. For this column, 1, 2, 3, 4, 5. It's going to sum this. I'm going to find this divided by the total sum, 2 divided by the total sum, 3 divided by the total sum, 4 divided by the total sum, and 5 divided by the total sum. So in that way, give it proportion. Also, 6 divided by the total sum of this column, 7 divided by the total sum of this column, and it just gives you that proportion table in that regard. And also, we have the add margin function, which this add margin function. And what does this one do? This is going to give you it's going to apply a function to say your matrix and give you the answer just beneath the matrix. It's going to return the whole matrix and give you the answer in that regard. So for example, if I apply it on this guy, add margin on the matrix column, and let me say I want to do it on the row level, give me the sum. I should run this. So this is your, let's say, yeah, it's, hold on. This is row. Where is it giving me? Let me check again. Is it supposed to give me this? 12. Okay. So what this one just did is that he added everything in this column and gave me the sum beneath. Added all of this, give me 40. Added all of this, give me 65. Like it's just to like aggregate the whole thing. Then if I want to do it row and column at the same time, I can just put it C into bracket 1, comma 2. Then just give me this result. So this is my matrix. This is sum across the rows, and this is sum across the column. Then this is what you have. Then it gives you this grand total, which is 210 in that regard. So that's what this one does. I think that is well explained also. So moving forward, we have cost tabulation. And how does this one work out? How does this work out? So here I'm using a table called beds. I'm giving a table called beds. So I want to cost tabulate quantities. This bed is a data frame. So I want to create like a matrix. I want to create a matrix with species and habitats. It can be like, you can say, a contingency table if you like. Species and habitat having the values as quantity. Now we have quantity, a quantity column. You have the species column, the habitat column, and the quantity column. But species and habitat is going to be my rows here, my unique rows, and my unique columns respectively. Now, what is going to be inside is going to be the quantity. It's going to be the values. So this is not a frequency table. So it's telling me that for garden and bed, the corresponding quantity is 47. For hedgerow and blackbird, the corresponding quantity is 10. For parkland and blackbird, corresponding quantity is 40, that is QTY. Now here is saying that for hedgerow and great teeth, the corresponding quantity is 0. So why is it giving me 0? It does not mean that quantity value in the data frame is 0. It's just trying to tell you it does not occur. It might not necessarily mean that it is 0. So it means that it does not occur. So for parkland and great teeth, the corresponding quantity is 10. So that's what it just does for you for the cost calculation. I think that is that for cost calculation. And testing cost calculation, you can check the class, or you can, I think maybe you can just check if it is the table function to check, because it's also a table. So also now you have the as function. Now as is like converting something to something. So let's say, for example, Farida is a doctor. He's known as a doctor in the R environment. So I don't want Farida as a doctor again. I want Farida to be a lawyer now in this case. All I just need to do in R is that I'll say as dot lawyer into brackets Farida. So what that's going to do is that it's going to change Farida from being a doctor to being a lawyer. That's just basically what it's going to do. Now in this case, beds.c, I think beds.c is a matrix. Now I want to change beds.c from being a matrix to what? Being a data frame. So what I just said as dot data dot frame. We use data dot frame. Data frame. That's data frame. So as dot data dot frame and just convert that to data frame. But sometimes I can just ignore this as I can just say data dot frame of beds. But I just use as data dot frame. For example, let me show you here. This my matrix M80, let me say data dot frame of M80. You can see it has been converted to a data frame. Likewise, I can see as dot data dot frame. So if I say as dot data dot frame, I'm on it. you can see I have the same result, but it's just that the columns that I have here, column that I have here, is just different to the one I have here, but I still have the same results. It's still converted into a data frame. So moving forward, let's talk about the data stream. Okay, and I think that will just be it for this session. We're about rounding up. I've talked about how to use the names command is to check the column names. You can also use to set the column name by specifying the names of the columns in a C function like this. So, and I think that will just be all. That will just be all for this session. So, do you have any question before we move to the next course, which is analyzing data using functions, loops, and data frames? Hello? Hello, are you there?
Yes, we are here.
So is there any question so far before we move on?
No.
So have you been trying to practice all of these things? Because I believe that if you are practicing these stuff, because you have your books, you have your lab, and you're practicing all these commands, you get to learn some things, and you get to see some things that might not be clear to you, and I want to clarify them in class like this. Like maybe you've done that stuff, and I'm still doing that same thing in class, and still don't get it. You might want to ask for clarification. So I will advise us we should always also find time to practice this thing through the week so that we can get to understand better as we progress in the class. All right, if there are no questions for now, so let's just move to this aspect of the training. So I think this aspect is going to be very, very interesting and it's very essential. Very, very essential. So in today's objectives, we are going to talk about the grids, matrices, lists, and data frames, index vectors, matrices, and lists. I don't know. I actually talked about this part before, but we are still going to talk about it again. That's indexing. Working with loops and functions, then install RADO. And the second feature of R is its capability to deal with complex statistical operations and can handle this using matrices, lists, and data frames. I think I've explained how these three behaves, what they are like, and what they can contain, and stuff like that. So I don't think I need to bother myself about this. Matrices are data frames containing list of homogeneous data in a tabular format. And say homogeneous data cannot take a single data type. So for performance arithmetic operations on matrices in R, either the elements of the matrix or the whole matrix can be considered as the value to operate on. If I have a matrix, I can say matrix times 4. 4 is going to be multiplied on that matrix. So for example, I have this matrix. MAT. This matrix. If I say MAT plus 4, the 4 is added to the whole matrix. In that regard. If I say MAT times 5 or times 2, is going to be multiplied to the whole matrix as you can see here. Now, how do you create a matrix? I think I've explained how to create a matrix before, but I'll still do that again. Now, we use the matrix function. The matrix function followed by the vector you want to use to create a matrix. So I want you to say, I want you to use the vector 1 to 20. And note that the size of the matrix is the number of rows times the number of columns. there's a parameter in the matches function where you specify the number of rows. So if I say number of rows, that is n row, I say it's equal to 5. It means that I will have 5 rows. And looking at my vector is of length 20. So if I shouldn't specify the number of columns, how is going to understand that the number of columns is going to be 4, given that I have a vector of length 20. But if you specify the row, the column, it's still not, doesn't still change anything. But if you specify the column whereby it is smaller, if you specify the number of row and number of column, and it is smaller than the size of the vector you are trying to create, or bigger, then you are going to get a warning when creating it, because if it is smaller, it's not going to use the old vector to create that matrix for you. If it is bigger, it's going to find a way to complete that matrix for you by starting all over again using the vector. I'm going to explain that. Now, if I want to give it a name, I can use the name names property. The name names parameter and say list into brackets. Then my row name is going to come first, then followed by my column name. So my row name, I'm going to put it inside a C function like this, and put my column name inside a C function like this. And that's going to create my dimension. That is my row name and my column name. So I don't want to create a dimension for this matrix. So if you want to create, you can do that. Now, for what is it called? Then you specify. Do you want it to create this matrix by row, or you want to create it by column? If you want to create it by row, you say by row is equal to true. But you want to create it by column, say by column, by row is equal to false. You want to create it by column. Yeah, I wanted to create it by column. Now, if I should run this, you can see what I have. It's creating my matrix by column. That is 1, 2, 3, 4, 5, column 1, 6, 7, 8, 9, 10, column 2. Depending, it's using this vector 1 to 20, then 11 to 15, then 16 to 20, column wise, because I specified by row is equal to 4. Now you can see that you use the old vector because my vector is of length 20 and the size of my matrix is of length 20, 5 times 4. Now if I should say my number of columns should be 5, which means the size of my matrix is 25. But the vector I'm using to create this matrix is of length 20. So there is no way I can create a vector of a matrix of size 25 using a vector of length 20. So, but how is going to create it anyways? But how is it going to complete my matrix? So after it gets to 20, it now starts from 1 to complete the matrix I'm trying to create. So let me run this and show you. You can see I have 1 to 5, 6 to 10, 11 to 15, 16 to 20. At this particular column, my vector has exhausted the element it has. So to complete my matrix, it now started all over again. Give me what? 1, 2, 3, 4, 5. So though it didn't give me a warning, it's supposed to give me a warning. I don't know why it's not showing the warning. Warning. It's supposed to show the warning, but let me run the warning command. Let's see warning or warnings. Warnings and print method. Print the variable large.warning in a pleasing form. Okay, let me see. It's not showing a warning. It's supposed to show me a warning. It's supposed to show me a warning. It's not showing it. But you understood how it completed your vector for you. But what if I specify a column? The number of column is 3. Now, in this case, my size of matrix is 15, but the vector I'm creating the matrix from is of size 20. So it means my matrix, the length of my matrix is smaller than the length of this vector. So it means that I cannot use the whole of this vector of the elements in the vector to create my matrix. So it's going to stop at 15. So the 16 to 20 is going to be disregarded. But if you want this now, you can see I have this. So the warning message came. I don't know why the warning did not come before. So you can see the warning here saying that the vector I'm going to use is of length 20. I know it's a multiple of number of columns 3. So it's saying that my matrix is smaller than my vector. So you can see that it stopped at 15. So 16 to 20 in this vector was out of the picture. So let me do that matrix of size 25 again. Let me see whether it's going to give me my warning. So it didn't be my warning, so I was just fine with it. But then it didn't create its property. It started from the beginning to complete my matrix for me. So that's just it. So moving forward. Okay. I think I've talked about the C bind and the R bind function. So you have the list. A list can contain anything. It can contain a list, it can contain a vector, it can contain a data frame, it can contain a matrix, anything you put inside. I'm going to take it. And I've talked about subsetting a list, but as you proceed, you can also talk about it. You also have data frames, which is like a spreadsheet kind of data. Which of the following R commands should be used to view the name of the column containing the record of employees? So this is just saying like this is wrong, this is wrong. Why is this wrong? I'm having two parameters, x and y. I can only have one parameter. This is wrong because the name of this, there's nothing like column names, it's co-names. And this is right because I say co-names xy. So xy is going to be the name of the table or the name of the data frame I'm trying to check the co-name. So this is very right. Okay. Now, next slide. Indexing vector. I can use positive integers, I can use negative integers, I can use character strings, I can use logical values. I think I've explained using positive integers, character strings, logical values. I don't know whether I'll talk about negative integer. Negative integer is going to exclude those values in that position that is specified. So if I have a vector called VEC, if I say VEC in square brackets minus 2, it's going to return the vector excluding the guy in the second entry. So for example, I have this VEC, this vector. If I want to exclude 4, 4 is in position 3. I just have to say VEC minus 3. So it's going to return VEC excluding the guy in position 3, which is 4. You can see that 4 has been removed in the picture. If you want to exclude many values, I can say the person in position 3 and 5 respectively. I can do this. Then this is going to exclude 4.
Sorry, Emmanuel.
Yes, sir.
In R, indexing doesn't start from 0.
Yeah, it starts from 1. Yes.
Okay.
So here, this is going to exclude 3. The guy in position 3, which is 4, and position 5, which is 2. So it's going to exclude 4 and 2 and give me the rest. If I should run this, consider 4 and 2 has been taken out of the picture. Now, I said we can use logical operators. That is VEC square bracket VEC greater than 3. It's going to give me the guys that are greater than 3. If I should run this now, you can see it gave me the guys that are greater than 3. So that explains this last part, vector of logical value. Now, subsetting with logical value. Now, what if I want to negate this condition? Say, okay, negate this guy. To negate a logical operation, you use exclamation mark. This means give me elements in VEC that are not greater than 3. If I should run this now, you can see these are the values that are not greater than 3. Just as simple as that. Just like the minus sign here. So this one just exclude, like negate the logical operation. So, okay, moving forward. Okay, I think I've explained this. I've explained this also. I use character string also. I can use logical operation. As you can see here, this one is saying give me temperature for values in temperature that are less than 15. Okay. Now, indexing matrix. The way you index matrix is similar to the way you index a data frame. All right. So this one is asking if you execute if you execute this command, what would the output be? I'm saying salary 3 to 5. This is the salary vector. 3 to 5 is going to be this to this, that is Q3 to Q5. So obviously it's going to give you this man here. All right. So now programming in first and built-in functions in R which are useful, like the sum, the max, the mean, the median, the minimum, and cum sum and the likes. But sometimes you have to create your own function by yourself to solve your own problem. Yeah, you have to solve your own problem by yourself. And some nice functions are created in R, like some really using loops and all. I don't know if I have some. I don't have. I don't have them here, but I don't have them here. I don't have them here. Let me see. I don't have them. I don't have them on this system. I've created so many functions. So depending on the kind of problem you're trying to solve, you create functions and all. Now, I think this one is very important. This is also important. Good expressions. I can run several line of code on a single line, separating them with a colon. So this I'm running these three commands in a single line, separating them with a colon. So this is going to assign A to 1, assign B to 2, then C is going to assign to A plus B. Then it's just going to print this guy because I didn't end it with a colon or semicolon rather. It's just going to print this last operation. So it's C. No, it's not going to print it. It's just going to assign it to C. So moving forward. What's wrong? It's taking time to. What's wrong? Hello, can you hear me? Okay.
Yes.
Okay, good. So conditional execution, talking about the if and if else statement. Okay. Mm, okay, I can do something. Say, the if statement is very essential. It's like saying that okay, if I score more than 70 or more than if I score up to 70 in my exam, it means I'll get a hit. else I will not get a A. Yes. So if the condition is true, then do something. Then what's going to be the implication? Else. Now else is when all other conditions are failed. Then you have else if, that is if you have multiple conditions. But they are going to, when you write a condition statement, you have to be very careful. First of all, the condition, the first condition that is paramount should come first. Should come first. So it's just like, okay, I have a someone I want to send to help me to get food, and let's say the favorite, the food I would like to eat is amala. So like you have a first choice condition, a second choice, then the third choice. Because you have three of them like that. Okay, my first choice is amala. So the condition I'm going to give the person first is that if there is amala in the canteen, then get amala. Then if my second choice is semo, it means that that condition have to be like, okay, whether you now get to the canteen, let's say you get to the canteen, there's no amala, then you consider second condition. Then I will now say else if, that is, given that the first condition has failed, then else if there is semo, then buy semo for me. So that is if there's no amala. So it means that you have to check for amala. Don't check for semo first. Check. Is there amala? Then if there's amala, then you get amala. But if there's not, then check if there's semo. And if I have a third preference, say wheat, then it's asked, you have to come and check the third preference. That is if the second preference, that the second condition did not also prove to be true. That is if there is no semo again, then check, is there wheat? If there is wheat, buy wheat. Then if I have to really eat, or if I don't want to eat any of those three, then I will say else. That is if all those three conditions have failed, bring back my money. It means I don't want to eat anything except from those three, but it has to follow a particular order. So else, that is if those three conditions, all of those three conditions now fail, bring back my money. So that the else statement does not need a condition, but it's built on whether other conditions have failed, then do the last thing for me. So last just bring my money if there's not. So that's just what it means. You can have if, just only if. You can have just only if. You can have the if and else. You can have if and else if, then the else statement. You can have if and else if only and no else. You can have if inside an if statement, depending on what you want to do. You just have to get the idea. So if, first of all, if has to come first. If a particular condition, do this. If you want to check another condition, you can check else if. Then if conditions are built on each other. So let's say, for example, I want to send someone to get amala for me. But that amala also is also subjected to another condition. Say, if there's ewedu, are you with me? So it means I have to have a nested if statement. So it means that, let's say my amala is conditioned on whether there's going to be ewedu. Are you with me? So it means that the way I'm going to structure my if statement is going to be like this. If there's ewedu, first of all, ask if there's ewedu, because probably they've sold amala for you. And you're not just asking whether there's ewedu. First of all, before you buy amala for me, check whether there's ewedu. Then you say, if there is ewedu, then another if is going to follow again. You can be a nested if, or you can write it on a single statement. So I can say if there's ewedu, if that is true, then check, is there amala? Then if it exists, then buy amala for me. That's a nested if. I can say if there's ewedu and there's amala, I can put it on a single line. So it's possible you can have a nested if, and you can have a multiple condition in an if statement. It can be that complicated depending on what you are trying to solve. But let's see how this goes well. So I think that background knowledge is well understood, well explained. Anyways, so now say let's just do a simple if statement. So let's say I have a particular a variable. A is 5. Let's say if a is greater than 0, the condition is going to be inside a parenthesis. Then what you want it to do is going to be inside this curly brace. Inside the curly brace, I'll tell you what to do. So if a is greater than 0, print a is greater than 0. I don't want any else statements. I just want to write only this. Now if I should run this, you can see it's printed a is greater than 0 because a is actually greater than 0. But if I change this to be less than, if I run this command again, it's not going to print anything, as you can see here, because that condition is not true. Now I can now put else statements here now. Say else, that is, if the condition is not true, what do I want it to do? Then inside a curly brace, I'm going to put what the else statement is going to do for me. Then I can say
A is not better than 0. Sorry.
okay.
Guys,
Okay.
just say something.
So here, if a is less than 0, I would say a is not greater than 0, right? Else, a is greater than 0. Then it's going to do this for me. If I should run this now, I can just highlight this and run it. You can see that he did not print this guy because what? A is actually not less than 0. So this is false. That's why I didn't print this. Then they now printed the else statement. So when this condition has failed, they now went to what? To print this. That's what else statement does for you. Now this stuff I did here. Now, I first of all wrote one particular if statement. Say if a greater than 0, and I did something like this. Print, what's it called? Print a is greater than 0. I did something like this before. Now this is 3-line code, Abby. Okay. What? what if I don't want to do this? What if I don't want to do this 3-line? Let me see if I can do this. I'll say if a greater than 0, and let me say this follows. I'm going this unexpected comma let me see. This should be a way up. Okay. How if I should put it? This. Okay. I'll come back to that. So no, I can actually put it on a single line. Say without this space, I'll just write my condition like this. Then this one for so if this print this. So if I run this, I've been able to convert these 3 lines of code into a single line. Now, when I talked about writing functions, stuff like that, I said we can ignore these braces sometimes. So that's what I just did here. It's as simple as that. Now, let's now come forward here. Okay, I don't want to talk about loops yet. So now you have also if else. So let me see if I can work it out with this. You know, this is what I here I did an if and else statement together. Let me see if else. So then I put the condition a less than 0. Then what I want it to do, if a is actually less than 0, should do this. Sorry. This is the if else function in this case. Do this. If it is false, then do this. That's just if else. So let me run it. Let me run it. You can see it say a is greater than 0. So I just converted this. How many line of code is this? Like 5 line of codes. I just converted it to a single line.
Sorry. So is it that if else comes after else or else comes after if else?
So this is a function. This is a function. This line is a function. It's an if else function. So if else function is saying that if this condition is true, do this, else do this. That's what this function does.
Okay, so this is like combining the if and else that is on top in one.
Yes, exactly. So now we can have multiple conditions. As I said earlier, I can say, okay, if a is less than 0, print a is less than 0. Now, and I can write another condition. You can see I came to the end of this brace, that's the end of the if statement, to write my another statement. And I say else if. This is how I write else if. Then put the condition again. Else if a greater than 5. Are you with me? Then put what you want it to do inside the brace. I don't want to put greater than 5. I want to put greater than 3. Then inside the brace, I'll say
sorry, can we use this example?
okay.
That if let's use the grade score of a student. If you score 90 and above, A. If you score 70 and above, B. If you score 60 and this thing. Let's say there are about 5 different conditions. How do we put it in this?
Okay, yes, you can do that. So let me create a vector. Let me create a vector that has like scores. Yeah, that has scores for you. So okay. You create a vector of scores. Want to say something?
Now, I wanted to say we can still use that A. It's just that if A is greater than 90, blah, if A is greater than
Okay.
80,
No,
all
A
those
is
things.
just A is just a single.
Okay, you have a vector there already. Okay, all right.
It's just a number. So scores. Let me just create a scores vector that has like list of numbers 6, 65, 70, 60, 35, 50, 55, 55, 1, 2, 3, 4, 5, 6, 7, 8, 27, 10, 6. These are scores now. So let's now say I want to now do like I want to give grades to this guy. So I want to give grades to this guy. So I can create a grades grades variable. I would say if should I use this? Should I use this? Let me see if I can use if else. So let me use if else. Uh, if else scores, or start from scores greater than 70, or greater or equal to 70. So let me use greater or equal to 70. This, then another if else. Inside it this way. Another if else scores greater or equals to 50, no, 60. That will be grade B. Then another if else scores greater or equals to 50. That will be grade C. And another if else says scores is greater or equals to, I think D is starting from 40. No. D is starting from, what is this starting from, sir? D.
You can use 40 also.
Okay, 40. So this is D.
So the last one will be if score is less than 40 is F. So everything from 0 to 39 is F.
Yes, everything from 0 to 39 is actually F. But I don't know where D is going to fall into, because after D,
Okay.
I'm supposed to have E. That's why I'm not. I don't know. I don't know. Oh God. Okay, 45. Let me use 45 here instead. I think this is good. That will be D. And if else, false is greater or equals to 40. That will be E. Then else, that will be what is going to follow. That's going to be F. Yeah. Okay. So I've done that statement. So let's see what's inside grades. Grades. You can see I have DBAA. What is this called? So let's convert to the data frame. So I'll say data dot frame of what's it called, scores, comma, grades, so that we can see it clearly. So this is what you have. So 45 is D, 65 is B, 70 is A, 60 is B, 35 is F, 50 is C, 5 is C, like that. So does that make sense to us?
Yeah, thank you.
So this is just similar to the way you are writing your conditional statement in Excel. So like if else inside the if else, then this condition is first of all checked, then it goes this, then write another if else statement, checks this, assign this. And since I still have another condition, I still have the if else, then and it gets to this 40, which is E. The last thing I can see is F. So the F does not need a condition. Since I've already put this, I just put else, just do this one. So just as basic as that. All right. So it's, as I've said earlier, though this is a sweet way of doing like a case statement, But sometimes you might want to write some nested if statement whereby you have to write something like this inside a loop, depending. So I think the concept of if is already um, explained here. Now the next thing we'll be going into is loop, which is very essential. It's very essential in data analytics. You you want to write loops to use like algorithms to solve a particular, to create even columns and do some computing. Then you have to do some while loops and for loop and all of that. Conditional statement inside a loop. It's, all of these things are going to compile together to solve problems. So it's very essential. You have to understand how it works. But unfortunately, fortunately, I don't want to use unfortunately. Fortunately, we won't be able to uh, go into this because of time. So we have two kind of loops. You have the for loop and the while loop. I'll give you an intuition of how this works out. Now, for the for loop, this is how the for loop works. It iterates over a particular object or container. It iterates over a particular container. Let me just put it that way. So if I have a store where I store books. Now, if you have a store where you store books, right? Now, and you are looking for a particular book. So everything is just not well arranged. It's not arranged. It's not arranged. So when it's arranged in a particular order, let's say it's not arranged. What you do is that, or let's say it's even arranged, but you don't know the order at which it is arranged. What you are going to do normally is that you are going to start checking one by one until you get to the book you are looking for. Or let me put it this way, you want to check the names of all the books in that store. It means you have to keep checking one by one and looking at the name. Then that is what the for loop is going to do. So what this one is saying, for counter in sequence, counter is going to like be looking into the sequence one by one, everything inside the sequence. Like what you have here, the for loop for I in 1 to 6. I is going to iterate through the vector 1 to 6, one by one. When I is 1, when I is 2. And if I say for I in 1 to 6, print I, what's just going to, is going to print 1 to 6. Unless you put a condition, you can put a condition that, okay, if I is divisible by 2, then print I. So that means it's going to print even numbers for you, but it's still going to look through all the elements in that container. Even if you are putting a condition, you're going to check, oh, when I is 1, it checks, is 1 divisible by 2? If no, it's not going to print it because you have put a condition. Then it goes to the next number. So it's just iterates over a set of values. Now for while loops deals with this. So this is the intuitive part of while loop. This is the intuition. So it's that while a particular condition is true, perform a particular task. So let's say, for example, in a particular company, some company might say, okay, when you get to age 70, then please you must retire from that company. So what it means that while my age is still, let's say age 70, while my age is still less than 70, it means that I am still valid to work in that company. But by the time your age gets to 70, it means you have to retire from that company. So while a particular condition is true, then a process is going to keep running. So that's what while loop does for you. So you can use this to do processes and say, okay, as long as this condition holds true, this thing should keep working, or it should keep doing a particular task. So that's what while loop do. We are going to do some examples under for and while loop in the next class. Because of time, we are going to stop the class here today. So I believe we all got one or two things in this class today. Faida, you have been quiet for some time now. I hope you are enjoying this session. Oh, oh, I think Faida went to pray. I think Faida went to pray. So, Mr. Sunday, are you with us?
I'm here.
All right. So that's where we are going to end the class today. By next week, we are going to continue from the loops by next week.
Okay. You promised to send us some links and materials.
Yes, that's true. Please, please
Then
just
the sample
okay.
questions you guys says you are compiling.
Okay. Yes, okay. I will also do that too.
My third question is, what's the last time to book for exam?
Okay.
Because this exam going to contain a lot of hard, and one has to learn all these functions, all this programming, how to, it's not something I
Okay.
want to rush into, but I just want to know all my options. Then, for those who fail, what happened? Do they only pay to receive the exam or what?
Yes.
Definitely, I'm not planning to fail, but I just want to have the
I
information.
understand. I understand. I understand. Yeah. So I think they pay a nominal fee of $50 to take the exam.
Okay.
Yes.
So,
All right.
in my own case, when is the last time I will sit for the exam?
Okay. So that question is dependent on when you were actually going to start on the DASCA platform.
Because you guys sent an email sometime ago and said we can start registering, that within 3 months or 6 months of registering, we have to do the exam, otherwise we have to pay again.
So if you registered on the platform today, that was when you got message from DASCA that you should go and confirm your registration and stuff like that, right? That's when you had access to your DASCA account. So let's say that date was today. Today is like 23rd of January.
Mhm.
It's going to take up to 180 days. You still have the grace of
Like
180
July
days, that's
23rd.
6 years, like 6 months before you will not resume to take your exam.
So
So
I have
within
to
that
have
period,
studied the exam and sit for it then before that 180 days, have it?
yes, before that 180 days is expired.
I think we started this lecture like November, isn't it?
This lecture, yeah, November, I think November 20. I think
So
November.
our home we should be aiming some March to be on the safe side.
Okay, like April actually. April. I think it gets up like April.
Mm.
Yeah.
Is it all this Prometric Center or something?
It's something you can take in comfort of your home if you have the
But we can come and take it in your office.